Welcome to Technova Podcast.
Welcome to the deep dive.
Great to be here.
So today we're diving into a story that really took off online. Started with this video from China's Tiangong space station.
Right, and it seemed simple enough, but it just spiraled into all this confusion, even some conspiracy theories.
Exactly. It's a pretty fascinating case study, actually.
It really is. It shows how our, maybe pop culture ideas about space can sometimes clash pretty hard with the actual physics. This video showed something that just didn't compute for a lot of people watching.
Yeah, definitely counterintuitive. So for this deep dive, we're mainly looking at an article from Times Now. They did a good job summarizing the online reaction and, crucially, getting some expert input.
Input needed to explain what was really happening.
Right. So that's our mission today, basically. We want to cut through all that online noise about the clip.
Figure out why it caused such a fuss.
That's exactly. And then bring in the science, the real science, to show that, well, it wasn't weird or fake at all. It was actually physics doing its thing.
A really cool demonstration, in fact.
Okay, let's unpack this then.
Let's do it.
So the video itself, the one that really got people talking, it showed an astronaut on the Tiangong station, and there's just an open glass of water sitting on a table next to them.
Yeah.
And the water, it just sits there.
Just stays put.
Yeah, it looks totally normal, like it could be on my kitchen counter right now.
Which, immediately flags something for people thinking about space. We see astronauts floating, pens drifting by, liquids forming these perfect little spheres.
Right.
So glass water just sitting, it seems wrong, defies the image we have.
Totally. And it's important to note this wasn't some leaked, grainy footage. It was part of an official program.
Yeah, the Tiangong class, right. China's educational outreach from space.
Exactly. Designed to show science concepts in orbit. And the full version of the clip, which the Times Now article mentioned, actually gives some really important context that got lost in the viral shares.
Huh. Okay. Like what?
Well, it shows the astronaut filling the glass really carefully. They used a straw.
Oh, right. That makes sense for microgravity, stops it splashing everywhere.
Precisely. And, maybe even more importantly, it showed them using Velcro.
Velcro. For the water?
No, for the glass. They used Velcro to stick the base of the glass onto the table.
Okay, so the glass itself wasn't just like magically balancing, it was secured.
Correct. But, even knowing that, the big question people had was still about the water inside the glass.
Right. Why didn't that just float out and drift away?
And that's where the confusion and, the conspiracies really seem to take root online.
Yeah, people work with this idea of zero gravity, right?
Yeah.
And the intuition is just, well, if nothing's holding the water down, shouldn't it just go?
And you saw that reflected everywhere in the comments. Stuff like, that water should be floating.
Or people directly questioning if they were even in space. Apparently they are not in zero gravity, things like that.
Exactly. And it wasn't just random commenters getting it wrong. This is kind of wild. The Times Now piece pointed out that Elon Musk's AI chatbot, Grok, apparently, if you asked it about the clip, it would incorrectly state that, yes, water would float out of a glass in microgravity.
Wow. So even the AI was reinforcing the misconception.
Yeah, amplifying the confusion. It's interesting.
Yeah, definitely. But thankfully, the Times Now article didn't stop there.
Yeah.
It brought in the actual science.
Right. From Jordan Bim. He's a space historian at the University of Chicago. And he basically said, look, this isn't suspicious. It's perfectly normal physics. The water stays put because of something called surface tension.
Surface tension.
Yeah.
Yeah, it's one of those things we learn about, maybe see with water droplets or insects on a pond.
Right.
But here on Earth, gravity is so dominant, it kind of masks the full effect of surface tension most of the time.
Okay.
But up there, in microgravity, surface tension becomes a major player. It's one of the dominant forces acting on liquids.
Okay, so break that down a bit more. What is surface tension doing here? Why does it keep the water in the glass?
So think about water molecules. They really like to stick to each other, right? That's called cohesion. And they also like to stick to other things, like the walls of the glass. That's adhesion.
Cohesion and adhesion. Got it.
So as Bim explained it, basically, the water molecules are more attracted to sticking to the glass and sticking to each other than they are to just sort of dispersing off into the air.
So it's not just this inert blob waiting to float. The water is actively kind of holding itself together and clinging to the inside of the glass.
Precisely. In that microgravity environment, and remember, it's not truly zero gravity, it's microgravity, meaning everything is essentially in a constant state of free fall around the Earth.
Right, that feeling of weightlessness.
Exactly. In that environment, those forces cohesion, adhesion. They're strong enough to hold water together and keep it within a container, overcoming the tiny residual forces that might otherwise cause it to drift out.
Okay, that makes sense. So the stickiness of the water, both to itself and the glass, is relatively much stronger when you take away the overwhelming pull of Earth's gravity.
You got it.
Yeah.
These forces seem subtle to us down here, but up there, they dictate how liquids behave. It's why water forms spheres when it floats freely, why it climbs up thin tubes, and, yeah, why it can stay quite happily in an open glass.
All right, so putting it all together, the video isn't weird at all.
Not in the slightest, from a physics perspective.
You've got the astronaut carefully filling the glass with a straw, securing the glass itself with Velcro, and then surface tension doing its job, holding the water together and keeping it adhered to the glass walls.
It's physics in action. Beautifully demonstrated, really.
And, some people online did get it. The article mentions comments pushing back, people saying things like, that's called physics, or, kind of snarkily. It's not like you couldn't just spend 5 minutes researching this stuff.
Hey, yeah, there's always that side, too.
Which kind of brings it back to you, the listener. This whole episode isn't just about debunking a space conspiracy. It's actually a great reminder of how these fundamental physics concepts, stuff maybe you haven't thought about since school, how powerful they really are. Gravity is such a constant, strong force here. It makes other things like surface tension seem minor. Like, oh, that's why water beads up.
Right. But change the gravity, go to orbit, and suddenly those minor forces are running the show for liquids.
Yeah.
It really underscores how much our everyday intuition is tuned to this environment, to Earth's gravity.
Yeah. And why maybe we shouldn't always trust our gut instinct when we see something from a totally different environment like space. Understanding the science is key.
Absolutely.
So wrapping this deep dive up, the key takeaway is pretty clear. That viral video, not fake, not suspicious.
Nope. Just a straightforward demonstration of surface tension doing its thing in microgravity, keeping water neatly inside an open glass.
A cool science lesson, basically.
Exactly. And maybe it leaves us with something to think about, a final little thought experiment for you.
Okay.
Well, if something as simple as familiar as water in a glass behaves so differently when you reduce gravity significantly, what other everyday things, experiences, phenomena might be profoundly shaped by gravity in ways we just don't even notice down here?
Huh. Interesting. Like, what hidden influences does gravity have on, well, everything?
Yeah. And what else can exploring these microgravity environments teach us about those forces that are acting on us,
Yeah.
shaping our world all the time without us even realizing it?